awesome for many reasons. He showed you how to build containers using SageMaker. SageMaker is built upon a foundation of containers. So in this session, the session calls for creating a random tree. I want to show you that it could be really easy. So I'm going to change the plan just a little bit. I know Chaitanya just asked you to turn off your SageMaker instances, but go ahead and open them back up again, okay? If you clicked stop here before, I'd like you to go ahead and click start. If you deleted your instance, I'd like you to create a new one. And while you're doing that, while you're just bringing up SageMaker again, I'm just going to show you a few foils, okay? Well, I'm old. In the old days, they were actually foils, right? But slides or whatever the proper term is here. So there's a couple of concepts. Just talking to the folks in the room, I can see that a lot of you guys are developers. I'm a developer too, right? There's a couple of things about working in machine learning that are very different for developers. So what I want to do is sort of break your way of thinking a little bit, okay? If you go into a Jupyter notebook and you know the answer that you're trying to get to before you start, you shouldn't be in a notebook. You should just bring up your IDE with a Python or R or whatever your language of choice is editor and write code the way you usually do. The reason we use notebooks in data science is really simple. Data writes code. And it is that simple and that important. Okay? You're going to spend most of your time in machine learning not looking at Python. You're going to spend most of your time looking at data. Okay? Data engineering, feature engineering begins with understanding your data, knowing the characteristics of your data, and then the most important part, I mean, the thing you really can't learn in a class like this. In a class like this, we can show you how to use our tools. The stuff you're going to learn by watching YouTube videos and possibly other classes or anything is feature engineering, right? Getting your data massaged, wrangled, getting the nulls out, getting all the data put together in such a way that a machine learning model can work with it is 80% of the job. So data writes code. If you have no data, there's no code. The number one misunderstanding of machine learning is that it's all about the algorithms. It's not. Okay? I live in New York City. I watch a lot of acquisitions that are happening in machine learning and companies that claim to be AI companies. I'd say I've seen about 40 in the past year. Not one of them had a proprietary algorithm. Not one. All of them had proprietary data. Right? So I just want to emphasize the importance of data. If you have bad data and you run it through a model, you're going to get bad code. It's that simple. If you've got good data, then you can begin. All right? So this is our starting point. Let's go back to, I'm going to assume by now you've been able to open up your SageMaker notebook. Let's open this up again. So I use SageMaker all the time. I use it for everything. It's kind of my go-to place, sometimes for even things you shouldn't use it for. But that's because it is a real simple platform to deal with. First of all, just a quick tour of these tabs up top. Oops, I guess I have to exit out of that. Thank you very much, Joe. Come back here. Thank you. So one thing is the SageMaker Examples, all right? So if you click on this tab, you're going to see more than 80 examples. Not only that, but yeah, I'm just going to bring up another tab here and type along with me, all right? This is a hands-on class. Just type GitHub and SageMaker Examples, just like that. And it'll take you to the GitHub repo where actually all of the SageMaker examples are. So take a look at the file structure here. We have advanced functionality, hyperparameter tuning, etc. This is the GitHub repo. Come back to our SageMaker examples pull down here, and you can see it was generated from that GitHub. So what does this mean? This means if you want to, you can do a pull request. You can add stuff to SageMaker. You can do that, right? So if there's something you don't like, or you use TensorFlow all the time, or PyTorch, and there's something in there you just really think would be helpful for the community, Add it, do a pull request. I mean, this is why we have it up there, right? So there's a lot of good stuff in here. This is a copy and paste library from everything Chaitanya just showed you, by the way, the containerization of certain algorithms, et cetera, down to just how do I do time series forecasting. Here's an XG boost model. Now there's two ways to use these samples. One is to just click on preview here and kind of just, you know, browse a little bit and see, well, is this the notebook that I wanted? Does it solve the problem that I'm trying to solve? The other way, and this is hands-on, so follow me, we're going to do this. Go down to where it says SageMaker Python SDK and open up this area, this particular category, I guess you would say. And scroll down to where you see MXNet MNIST. Now, MNIST is pretty much the hello world data set of almost all machine learning. What it is it's a collection of over 70,000 handwritten numbers, 0 to 9. So we're going to create a very simple neural network to categorize those handwritten characters, and we're going to test it live. And once again, this is off of sort of the prescribed path. I just wanted to show everyone how easy this is. So instead of previewing, we want to use this particular notebook. We're going to click Use. Go ahead and click the orange button, Use. And that brings up a little prompt here that says it's going to copy this file into your home directory. So click Create Copy. All right. So now we've got a new executable notebook. If I scroll down here a little bit, I'll see that we have some code here. And there's a lot of header in here. I wonder if I can just get rid of a little bit of this. Let's toggle that. And I don't need the toolbar. You don't have to do that. I just wanted to get a little bit more on the screen for you. Now, one thing that's really, really critical using SageMaker is keyboard shortcuts. I use them all the time, and what I recommend is if you just hit Escape H, go ahead and do that right now, you'll get a listing of all the keyboard shortcuts in Jupyter. If you do that every time you come in, after 5 or 10 times, you're going to know them, right? So keyboard shortcuts are really important. Pardon me? Escape H. So Escape H, right? So you'll see right here, this, if I click in here, right, this is a more markdown syntax. I got rid of my toolbar, so there's no run button, but the keyboard shortcut is Shift-Enter, right? And that executes, and it takes the cell and actually converts the text. Now, the first thing I see in the first cell here is that I need to give my SageMaker, tell my SageMaker where my data is, right? Where I'm going to put my data. So I have to fill in this bucket name. Now you'll see this in every one of our sample notebooks. So I'm just going to very briefly, let's see, I guess I'll actually bring up S3 over here. And I'm sure you heard this a few times today, but you have to make sure that your SageMaker instance and your bucket instances are in the same region, right? So if I come over here to my SageMaker console, I could see that I'm in Oregon. I think most of you are in North Virginia. So when I come over to S3 and I choose a bucket here, why don't I choose this one right here? I'm going to make sure over here that I'm in the same region. Now here I am in US West Oregon, so I know that I can use this particular bucket. So I'm just going to, well, I'll click on it like this and I'll just copy the bucket name. Right now, I'd like you to do the exact same thing. Just find a bucket that's in the region where your SageMaker instance is running. And you would think I could just copy and paste that. There we go. Pardon me?
It's so hard to copy
I know. No, we're good, we're good. All right, so I know that this is in the Oregon region because I checked. I know that SageMaker is in the Oregon region because of the little pull down is there is telling me that. You have to match your regions too, okay? Now we're going to come back to the notebook and I'm going to replace everything in the brackets and the brackets themselves, and I'm going to put my bucket name there. And that's all you have to do. And this is the same routine for every one of these notebooks. So just as I did, here's a properly formed S3 URL. So it's S3:// my bucket name, and then don't touch the rest of this. Is everyone there with me yet? Okay? All right, great. All right, so we want to execute this cell, right? Just hit Shift Return. So that gives you what I call the poor man's spinning ball. That's this little guy right here. And that means that the code is executing in the background, right? Now, if I wanted to do something special here, like if I wanted to put a new cell underneath the cell that I have here, I do Escape B, that puts a cell there, right? It's currently a code cell, but I want to put Markdown there, right? Escape M converts that to Markdown. And now I can put something here in Markdown and say, something like, now the fun begins. All right, I hit Shift Return, and that executes, and I've added a cell. All right, so I just want to, once again, kind of show you the basic stuff here. Now, we're working with a file that exists in the directory that we're working on. Remember, a lot of folks have a lot of Python code that's already written in your framework of choice. We're going to actually use an external file here that creates an autoencoder actually. So you can use any Unix command by just putting a bang in front of it. So we're going to cat this out, and we can actually see the contents of the file. This one happens to be using mxnet. It opens up a file that's in that directory. Now here's where we build the actual computational graph, right? This is mxnet syntax. We've just got a bunch of fully connected layers. We're going to take it at 128 to 64 to 10, and then we're going to softmax it. There are 10 digits in our number system, so it makes sense that our output of the neural network would be 10 and would softmax that output. Now, I know that this is not the best way to do this. I'm just exposing the code so everyone kind of sees, this is a real simple computational graph. Now, this exists just in the file system, and if we were to go over here, you don't have to follow me here, but if we were to go over here and go to the file system and go into this directory, we would see it here. Here's the file, right? Jupyter is just a file browser like everything else. We could have just come over here and clicked on it and done the exact same thing. All right, back here in notebook land, we want to execute some more code. So just as you see here, there's an mxnet wrapper. We also have a TensorFlow wrapper. This is just a wrapper. It's going to take your file, this code that you, in theory, already know works. We're going to say, what kind of instance do you want it running on? We're going to say an M4, instance count of 1. We're specifying a few hyperparameters here, just one actually, which is the learning rate for the algorithm. Hit Shift Return. So you should now have executed only 3 cells. Now we're going to run the training job. So let's train. Just hit Shift Return. When you do that, the job starts training. And you'll get some output in your notebook that says we're training. So here we're training in the notebook. So as I said before, you can train in the training session. Hang on a second. Yeah, here we're training in the notebook. Now, how do you monitor that? Well, I'm just going to bring up, you can bring up PowerShell. I'm bringing up an Ubuntu container. But if we type here AWS SageMaker help, we'll see on the CLI that we have all these functions here, all of these commands, right? So one of the things we could do is describe our training job, right? So describe training job. That's what we want to do right now. We want to actually look from the CLI. We want to say SageMaker, AWS SageMaker, describe training job. And it's going to want to know the name of the training job. It's going to want to know the training job name. So let's put that argument in there, training job name. And you'll see in a moment why I'm asking you to do this. I'm going to come back over here. The training job name was created for us algorithmically. So I am going to copy it from my notebook, and I'm going to paste it right here, thusly. And now we can actually see this job as it's training. We can see the characteristics of the job, and importantly, now it's coming out in this flat file output, but you can also change the format so that it's JSON, so you can change this to many things. So what it says here is that the job is starting. I'm going to hit it again. It's still starting. So what does that starting mean? I told you SageMaker is built on a foundation of containers. What it's doing right now is copying over the training container and marrying it with the model that we just uploaded in order to train that model, right? Now, the actual execution time of that model is going to be really, really brief, okay? So often when you're using these notebooks, well, what I do is I'll use scikit-learn or SciPy or one of the popular frameworks that are out there to do simple things, right? So I won't really go to the training section to launch a training job unless I'm sort of in the last steps, unless I'm doing all the data. Because this 2 or 3 minutes that it takes to start up the training job can be, it takes time. So while that's running, I want to show you one other thing, and you can follow me over here. If we click on training jobs from the dashboard, you'll see this job. It says it's in progress. If we click on that training job, the one we just pasted into our CLI, we can see more statistics, and importantly, down here at the bottom, we can get access to our logs, the training logs that'll be produced, and some instance metrics on this, on the instance that we give. Now, this is all the stuff Chaitanya just showed you, right? This is all the stuff we just did sort of coding, coding-wise. But here we're just hitting Shift Return on our notebook, and we're getting these results. So let me get rid of this. All right. So here's the output. We've started creating some output from our job. I'm going to go back here, and I'm going to get rid of that. OK, good. So it looks like the job trained. Here's our output. We'll go down to the bottom. I think it ran 30 epochs. And then here we are at the bottom, and we see 100 billable seconds. But wait a minute. That took like 2 or 3 minutes to run, right? But we have like 100 seconds. So I'm just describing loading up that container, getting the job running in the queue. That's what that overhead is. It's not a problem. It's actually the way things work. It's fine. Just put that into your workflow as you're beginning to use this. Is everyone with me? Yep, cool. Let's execute the next command. This one's killer. You might have heard me mention in the previous introduction that we've really taken care of deploying models in the cloud. Well, here it is. It's one command. It's deploy. Hit Shift Return. What that's going to do is it's going to take your trained model, and it's going to marry it with another container. This one's your execution container. If you go back to, and go ahead and follow me here. I'm sort of showing you all the control panels in SageMaker. If you click on Models, you will see here our newly minted MNIST identification model, the very, very top. We could see that we just created an endpoint configuration. So what's an endpoint configuration? I'll tell you in a moment. Because we're sort of taking the simple path here. We're going to create an endpoint, but when we check the status here, we see it says creating. So while that thing's being created, let me go back to our PowerPoint presentation and just talk briefly about deployment. All right, this is one of my favorite animations. So when you've got a model and it's in your ECR registry over here as a container, as a Docker container, and you want to deploy with SageMaker. Now, we did it with one command, but when you open that up, you can add a lot of arguments. What you're going to do first is create an endpoint variant. You're going to say, what kind of machine do you want to run on? Here we're saying it's a C3. Oh, I'm pointing at my own screen, so I can't really tell what's going on up there. We're starting with an initial instance count of 3. So that means there are 3 EC2 instances of the C3 class that are going to have this endpoint available at a single endpoint to service those requests. We'll call this one prod, and we'll call this variant name primary. Now, when we put that thing in production, first time, day one, this model, it's going to get 100% of the traffic, and it's going to create the most valuable asset in your company, which is ground truth data, right? So that ground truth data is going to go to S3, and you're going to use that to train your next model. Now, when you put your next model in, you very likely won't want to just switch and give it 100% of your volume coming in. In this example here, we're allocating 20%. Maybe that's high. Maybe you only want to put 5 or 2. But you're going to want to validate, is this model better than the previous model? Now, this could be a recommendation system that you may need to update 4 or 5 times a day. We have a CI/CD environment called SageMaker Build. It's, once again, another public-facing GitHub repo. In fact, Chaitanya is doing the next version of this thing, so it's something that's really in active development and really, really useful. Eventually, that model takes over 100%. You have more containers coming down the line, and so you're continuously feeding now the same model, the single endpoint, I should say, with new and constantly refreshed and better and more accurate models. Okay, so that's the general flow around how we use containers in deployment. So it's containers in training, it's containers in deployment, and now thanks to the previous demo, you have all that code. You have all that code that you need to construct these things from scratch. Question?
This 80-20 split, is that a configuration that you can go in someplace and say, okay, if this model is giving 90% of the conference higher, just switch it?
Yep, and you can do it in Bash. Using those SageMaker, I mean, you can dig into that a little bit later, but you just update the endpoint variant. You could do it in Bash, you could do it in the GUI. In fact, let me get rid of this and this. But that's what these endpoint configurations are here, right? So when we come in here, we see that we have our model. Here it is, there's the model. We have our instance type, and then the endpoint. There we go, let's dig into here. Now the endpoint itself, where are the variant settings? Here we go, endpoint configuration settings. And I don't see the variants here. Where is it? I'm sorry, I'm skipping over it.
Endpoint configuration settings, all topic.
Oh, there we go.
All topic and it's
Yeah. Right here. No, that's the model. You guys could see it, but I can't. All right. Uh-huh. Oh, okay, got it. All right, thank you. All right, so I'm not going to touch that. Well, I'll cover batch transform last. Let's come back to the model here. Okay, so that is progressing. Now, what's happening here? So here we're not so concerned about the size of the container that's copying out from S3. Here we're actually constructing endpoints. So this is a lot of heavy lifting. If you've ever had to try to put a cluster together that's serving a machine learning endpoint, then you have an appreciation of how much heavy lifting is being covered by this single command. So that'll just take a few more seconds to execute. While that's executing, and I hope that's everyone else is running this, what I want to do very, very quickly is come over here to training jobs. Now, to really, really simplify this, you don't even have to code. If you have your data set and you come into training jobs and click create job, which is all I did right here, you can choose from one of our, right now I think we have 14 built-in algorithms. So let's just choose k-means. K-means is a real common clustering algorithm. If you come down here and you say, okay, well, we're looking for maybe 10 again. We're looking for 10 clusters in our environment. I don't know what I forget off the top of my head what the dimensions are of the histograms for those. Let's just say it's 256. So you fill out your hyperparameters here, and you can essentially run this exact same model on the data. So if you're working with interns or something, and you just want to have them run a bunch of jobs, they can do it all in the GUI, right? You can set that up so that they can do that. You're going to say, where's the input? You're going to say, where do I want the output? And then we generally tag things for billing, right? So everything could be tagged for billing. All right, I'm going to come back over here. We're probably close to or actually in deployment now. And that was our training data. Good. OK, so we have deployed. We're in production. If I come over here and look at my endpoints, we see that we have, well, I have a bunch in service. Don't do this, by the way, because that costs money. But here's my new endpoint that's in production. OK, so there it is. It's available for you to call from this URL. But we're going to do it from the notebook. So follow me now to this cell where it says we're going to create a little drawing template. So just hit Shift Return here, and we're going to put a number in here. All right, so I'm just going to start real simple. I'm going to try to draw 1, provided I don't pick my finger. Let me clear that and just do a simple 1. There we go. Do the same thing. Okay, now we're going to call predict, right? Machine learning is all about prediction. The command for almost every model is called predict, right? So hit Shift Return, and let's see what our results are. Well, we have a lot of data here, but the most important thing here is at the bottom. It thinks I drew an 8. But notice that it's a pretty low probability, 63%. I'll probably dismiss that. Let's see if I do better with 2. Did anyone do better than I did? Good. All right, so I'm going to do a 2. I'm going to come down here and hit Shift Return again. There it is. Now it's a 2 with, what is that, 5 nines there? 5 or 6 nines? So it's really sure that I drew a 2. All right, so, play with this. It's fun, but I wanted to do something simple because we kind of did a lot of complex things. And I just want to show you how simple SageMaker can be. Okay? So when you're coming up with your ideas, your creative concepts, building models, I'd like you to be able to navigate SageMaker this way, work with the notebook so that you can explore your data, get it formatted in the proper way to load into either algorithms that you create yourself, or, and I'd like everyone to follow me here, open up a new tab and type this, SageMaker Documentation. I know. SageMaker Documentation. Now, click on that, and now click on this PDF marker here. Okay? Save that and put it on your phone. Got it? Save that and put it on your phone. This is a great doc set. And how rare is that? So if we come into here, and we chose k-means before. I'm just going to scroll down, and I'm going to go to the k-means algorithm here, and I'm just going to click on that. Not only do we tell you here what that k-means algorithm is, we give you all the basic input and output information about it, how it works. We give you, pretty much everything you need to understand this, including external references. We have a special approach to clustering, especially large data sets, called k-means++. So we describe what all that is. We describe the hyperparameters. So it really gives you everything you need to really understand k-means. And that's just k-means. You can pretty much go to every one of the algorithms, the built-in algorithms here, and you'll learn about the number one, the most popular algorithms. And you're going to be doing linear regressions. You're going to be doing classification, maybe with XGBoost or a random forest. Or you're going to be doing clustering with k-means. And really, if you're standing in line at Starbucks, or I live in New York City, this is a great thing to just pick up on the subway or in an airplane. I've learned more from this documentation than I have from Andrew Ng or half of the stuff I see online. Siraj, even though I love that guy. This doc set is really one of my favorite things. PCA, this is another really basic thing. All right, good. So I hope you had fun playing with that. But as was pointed out earlier, these endpoints cost money. Almost every one of these built-in notebooks has something here that says delete endpoint. So I'd like you to ignore that for now and come to the SageMaker console. And in the SageMaker console, click on Endpoints. Now, I have a whole bunch of endpoints here that I'm paying for. That's not good, right? So you want to make sure you don't leave these things just hanging. So why don't we all go there right now and clean up? It's the end of the day. So if you have an in-service endpoint, just click on that, do delete, and it will delete the endpoint. All right? Now I'm going to do that again for the endpoint that I just created. I'll say delete. I delete it. If I go back to my notebook, go ahead and do that. Come back to your notebook and do Shift Return. You're going to get an error because we deleted that. All right, that's good. That's a a positive, a true negative. So that's good. You want to clean the stuff up. These endpoints can cost money. We want to get that out of the way. All right. I'm going to move to talking about integrating machine learning into your environments next. So we're done with the notebooks. Before we leave the notebooks, while everything's up here and running, does anyone have any questions? Yep.
So, do configurations of other things have cost incurred to it also?
Good question. Uh-huh.
So it's really not so clean script.
Uh-huh.
For any of this stuff.
Sure.
We're on multiple environments,
Uh-huh.
East, Oregon, Ireland.
Mm-hmm.
So it's going to take us an hour to go through. So what is the best?
Okay. So just for the kids at home, the question here is, how do you clean up so you're not spending any money? First of all, there's a bunch of scripts that are in GitHub that you can just download. And what they're going to do is something like this, right? I'm going to clear my screen here, and I'm going to say SageMaker AWS, SageMaker. I'm going to say help again. Now, what you're going to want to look for here is you're going to list, here's your list your endpoints. Now, your original question was what costs money? What costs money is having live endpoints that can service, with 6 hosts, servicing requests, right? So you want to shut those down. Those are probably the most expensive thing to leave hanging out there. Now, you can stop your notebooks, and when you stop the notebook, you preserve all your data in the notebook. You're not going to lose that. That'll take up a tiny, teensy-weensy fraction in your S3. I'm actually... I think it's accounted for in SageMaker, not in S3, but it gets stored in S3, right? So a teensy tiny little bit of storage there, but that's pretty much it. Now, you can certainly write a script to list your endpoints and stop them, or rather delete them. And these are just while loops. They're less than 12 lines of Python. You go through each region, find those, et cetera. So it's pretty easy to write that, and there's a bunch on GitHub. In New York, at AWS, everybody just tells Alexa, hey, Alexa, shut everything down, or shut down my SageMaker, and Alexa will do it for you, right, with a Lambda. So, or I guess it's SageMaker skills now. Yeah. Well, let's put it this way. You do what you need to do for your environment, right? And as a developer, you're very likely going to delete that stuff, right? In production, you probably won't have access to the production instances, right? And that's where, let me just show you this very briefly, this GitHub that we've been developing called SageMaker Build. So SageMaker Build is built on Node.js and Amazon step functions. And it's a pretty hot product, actually, because what it does now, at least the current incarnation. Let me bring up another deck that has this here. Where is it? Integrations. Is it this one? Maybe it's this one. Come down here. Oh, here it is. So here's a diagram of the workflow here. And I wish I could see this. There we go. So what this is doing is it's saying once your model changes, you're going to trigger a Lambda that is going to take your code out of code build, which is where we're assuming you're keeping it. It's going to take your training image and create a new image with the SageMaker training job. That will then create what we call model artifacts. Why do we call it model artifacts? That's because whether you're using TensorFlow, MXNet, PyTorch, Keras, it all comes out in a different format, right? So rather than try to say what that format is, we just say model artifacts. Now those model artifacts now need to be married with your inference image. That gets loaded to your endpoint variant, and then that gets loaded up the same way I showed you in that animation earlier. Now, what we're doing now to improve this is we're having additions of the data set triggering retraining of the model. Right now, it's just doing it off of updates to the model itself, but this will improve over time. All right, so, well, I just happened to go to the integrations presentation. So are there any more questions before I talk about this? Yeah. Sure, yeah. Yes. Okay, so the question is what's happening in the background when we launch a production instance of our endpoint variant. Everything that happens when you do anything on AWS, essentially. So you are consolidating the endpoint to point to whatever number of machines that launched with that instance. However, once that's up, you can manage it using all the ordinary auto-scaling features, all of the redundancy features, so you can do a health check on the endpoint. If it goes down, you can launch a new one, etc. So, you know, sort of the Reader's Digest version here, where you're just sort of launching it straight from the code, is pretty minimal. And that's great, because you want to get that stuff in production quickly. But once it's there, it's just like the same way you manage EC2 in general. All of the same tools, all the CloudWatch metrics, all that stuff still applies. So you can scale up to thousands of instances, not a problem. Hopefully you'll need that much, because that means that's money, right? Your business is doing well. But yeah, that's the short answer. Everything you know about AWS architecture applies. All right, cool. All right, so I'll just mention very briefly, I'm with the Amazon Partner Network. The Partner Network, if you're in a startup, I encourage everyone here to register. Registration's free, all right? There's more than 50,000 registered startups or companies that are a part of the Amazon Partner Network. Over time, as you engage more with AWS, you're going to require more services, your company's growing, and we do more for you, right? The pinnacle of this, you can see the sort of stairway here is registered to standard, advanced, and premier. The pinnacle of this is the competency group. These are groups that not only demonstrate because they're successful in business, that they know what they're doing, but also we've vetted them. So we've gone through all of their, we've done well-architected reviews on them. We've ensured that they're robust, they're global, they can withstand traffic that comes with getting highlighted at AWS. Here's just a few of our partners that are ISVs for data pre-processing. Like I said, that's 80% of the job. So I just wanted to highlight that very quickly. But now I want to go to actual real-life use cases. And do I want to skip this part here? Yeah, skip it. I like that picture, but I'm going to skip it. OK, so here's something unlikely. Oops, that's not what I wanted. Oh, and I just killed the wrong one. Hang on, let's get this back. All right. All right. So Allied Van Lines. Now, I've said many times, and I'll say some more, machine learning in its current incarnation is about prediction, and essentially three things: predicting a number, a class, or discovering a cluster. So let's think about this. This is a real, somewhat pedestrian topic, right? I mean, when you think machine learning, don't you think of like Neuromancer or Blade Runner, and robots are going to come and they're going to kill us and take over and everything? But Allied Van Lines has classic problems for almost any company. There's seasonality. There are times of the year when more people move than not. They have to move a lot of equipment around, the logistics around this, everything from staffing to predicting demand is part of their ordinary business. Now, they've been using SageMaker, and they've worked with one of our AWS consulting partners called Paraveda to create using Deep AR, which is an algorithm that does time series analysis to predict seasonality, to do operational efficiencies around every aspect of that logistical pipeline. They've also been using XGBoost and hyperparameter optimization to fine-tune the models that they've created. So it's actually a really sophisticated model that has led to a number of efficiencies in the way that they operate. Now, here's a few more use cases. Urban Zoom is using prediction to price specific homes in certain areas. Digital Globe is sort of one of my favorite use cases. They're taking digital, rather satellite photographs of the planet. I think it's, I don't want to get this wrong, I think it's 5 terabytes a day. Photographs of the planet, sending it down to the Earth, putting it in S3, and then for commercial and military purposes, they have customers all around the world that use that data. Now, when we have the fires in California, which I like to call the ritual burnings of the mansions, which we have to sacrifice for our lifestyle, they use those in real time to help firefighters get to areas safely to prevent the burning of the mansions, actually. So Digital Globe's a phenomenal use case, and they were really early adopters of SageMaker. Fintronic is another financial category. They've reduced their deployment time for machine learning algorithms by 70% by using some of those utilities that I just showed you. Grammarly, if you use YouTube as much as I do, you see the ads all the time. Clearly, they're using natural language processing in their system. I didn't really spend a lot of time on the built-in SageMaker algorithms, but when you look at our managed services, like Translate and Transcribe, all of the algorithms that we use to build those managed services are built into SageMaker. So, I spend a lot of time traveling. I'll be in China and India. These countries have dozens of languages that, Google and Amazon were probably never going to build into our Translate programs. But you can do it. If you have a dialect that you want your customer service language to be in, you can use built-in algorithms in SageMaker to do that. So language processing is a huge part of the current renaissance of machine learning. I'll just point out one more thing, too, about language. So language processing is probably where a lot of the state-of-the-art is right now in deep learning research. And it's having really interesting unintended consequences. So DeepAR, which is our time series predictor, actually uses an algorithm that was originally used called sequence to sequence to do language translation. What DeepAR does is it's a regressor, but when you have really, really large data sets, you can't just take that whole data set and look back and understand and predict what's going to happen. What you want to do is sort of slice it into windows. So just as when you're translating from one language to another and you need to, that's not the language they use, but sort of slice it into windows, look back at your various words that preceded the word that you're in now. They've actually used that same algorithm. It's called autoregression. So it's a deep learning autoregressive approach to doing time series prediction. Intuit, another early adopter of SageMaker. Most people think of Intuit as the tax preparation software company, but they're actually one of the largest transaction processors in the world. So what they're doing is they've created their own custom feature sets all around fraud detection, so real-time fraud detection. And when customers come in and they try to process a transaction, they're immediately running that against those algorithms, and then they're taking the ground truth output from those algorithms and running that through Spark and Kafka. They're aggregating that, creating a new feature set, retraining the model, and using all the features that I just showed you to keep those models continuously retrained and in production. Just a few other things, Realtor.com. Obviously, they're doing prediction on housing prices based on the characteristics of the area. Sensing feeling is interesting. I made this point earlier, and I'll make it again, because I think it's really important. What sensing feeling does is they'll use computer vision to determine the mood of the person who's using the phone at a particular time. Now that's an interesting concept, right? So there's a couple GitHub repos that can detect, I think it's 7 facial expressions very quickly and very easily. I'm pointing to GitHub because it's on the phone. Of course, our own managed service recognition does this as well. But think about that for a minute. Everything you see and everything you hear is data, right? You can take audio and process it and turn that into data. You can take the video that's in the front of your phone, the back of your phone, et cetera, and turn that into data. So that's a really important sensitivity to have as you're designing new apps today. So at any rate, sensing feeling is an ISV that has an API that does that. And some of the heroes that you might expect, Thomson Reuters, obviously, they provide real-time stock analysis for their customers in the form of various products. And I think that's pretty much it. So here's my question to you now. you've learned about a lot of these algorithms and approaches to doing machine learning today. I've walked through some real-life integration examples. I would like to turn it over to us now and just spend the last few minutes of this. And I just want to ask you, and I hope that some of you don't mind saying out loud, how you're going to actually integrate machine learning into your apps. Does anything just stand out as immediately, like this is something I'm going to start using tomorrow? Anyone want to speak out? Did anyone come in with a preconception saying, I want to learn how to do this? Yeah, please. Mm-hmm.
I'd like to build like a machine learning model for SAT, ACT prep.
Okay. Okay, right. Test preparation. So can I just, actually, why don't we get the microphone so we get everyone's comments? So when I think about building a better educational system, the first thing that occurs to me is how do you label the data, right? Because most of machine learning works off of supervised data. So have you thought about how you're going to label the data as you build the system? It's okay, it's okay. But I mean, this is for everybody, and this is why I want to have an open discussion. So, you know, less than 10 years ago, computer scientists generally thought we wouldn't be able to make a self-driving car. And one of the reasons was, well, IoT was blossoming. And we had accelerometers, we had cameras that could do everything, we had essentially had proprioception, vision, hearing, everything we have as humans when we're driving a car. But the number of if-then statements that are required to analyze every condition at every time went into the tens of maybe hundreds of thousands. With deep learning, what we did is we completely changed, it was a complete paradigm shift. We were no longer saying, what do we do for tens or 100,000 conditions? We just say, here's the data we have now, what would a good driver do? That's all it came down to. So when I think it, if you don't mind my hypothesizing a little bit, some students do better than others as they're taking these materials. And that comes out in a number of ways. How much time do they spend on the screen, right? Do they scroll? Do they go back? I mean, these are all characteristics that you can begin to measure. And as you measure how they're using the app, you capture that data. And then, did this student improve over time? And that's, I mean, that could be binary. It could be a yes or a no, or you could say this student did 25% better, et cetera. So that's a sort of an idea of how to begin to label that data. And then as you begin to play with that data a little bit, you'll say, well, this whole program can be improved if we ask these kinds of questions or take this kind of educational path. And then you test it, right? And you have all that data that you labeled before so you can measure it again. So the point there is when you begin your machine learning app, think one thing, how am I going to label this data, right? If you don't have labels at all, well, and you have data already, use k-means, cluster it. Look for groups in your data. So that's another thing. Once you find those groups, you're going to eyeball them, right? So you're going to say, okay, wow, it turns out that in this group of students, there's about 15 different clusters, 15 different behavior models of how they learn. And then you begin, right? So just a few things to kind of, anyone else want free advice? Do you mind? It's just for everybody, please.
The example that you gave is supervised. Don't you have an unsupervised example? Or
well, what are you building?
We're thinking of, this, for example, when people send emails about the issues that they have, we automatically detect, certain things in the emails or the kind of problems that they have and match it to the known issues that we have and then generate models, matching it to the known problems and based on that we do routing and all that kind of stuff. Okay. There is no supervised. We don't preconceive, so these are the issues and these are the products that are associated to. It's self-learning.
Okay.
That's why I'm asking.
Reinforcement learning?
I'm sorry?
Is it reinforcement learning?
Yeah, it's reinforcement. If there's errors, it gets corrected.
Okay.
So, do you have like examples like that?
Yeah. First of all, nobody could hear you.
Okay.
What I heard is that you have a customer support model. And that when people ask questions in this customer support model, as they use it, it improves based off of the feedback that you're giving it. So how does that feedback come? In what form?
The agents
The agents. Okay, so the agents label the data. Yeah, so there you go. So you start off with unlabeled data, but then by just using the app, the agents are labeling the data, and then over time now you can begin to cluster that and classify the data and improve your model. There's one other really important thing. I don't need the mic because I have this. Is comprehend. So comprehend is a neural topic modeler. I encourage everyone to take a quick look at that. What that will do is it will take your corpus of customer support language and find key phrases, organizations. It will find things that, like a SQL statement, it just isn't going to find. And then, as you're doing your processing, perhaps using Alexa skills or a chatbot like that, you can query not only the stuff that's obviously in the text, but things that were derived using comprehend. So it creates a much better experience over time. So comprehend, it's an LDA model, latent Dirichlet allocation. So that's exactly how you do topic modeling with that, and it's really useful for the use case that you have right now. Okay, who else? There we go. Oh, good.
Hello? Oh,
there we go.
Okay, so we want to build a customizable proofreader for specific news organizations so that they don't have to hire human editors, but the text that we suggest them would be similar to the text they've already written. So it's pretty much an unsupervised task, as I can see.
Okay, so what I'm hearing is you're doing, hold on to the mic, we're not done. So you want to automate a proofreading task. So that would be checking for grammar.
Grammar style and
grammar style,
other
accuracy.
things.
Would you also be looking for links to other articles that have already been written?
Yes.
Okay, right. So once again, comprehend is a really great solution. The algorithm behind comprehend, like I said, is LDA. And because both of your data sets are going to be unique to your company, you'd probably want to use LDA and SageMaker. Put all your historical documents in S3. Just point the bucket, essentially, at the LDA. You could do this all from the GUI. You don't even need to write any code. And that will automatically go through and create all those keywords, et cetera. Now, as for grammar checking, that I can't give you any advice and guidance on, although I would expect that the literature is pretty good right now in GitHub for that. So doing sort of automatic semantic corrections and things like that. Where I think the real power of this is going to come in, though, is on cross-referencing the articles to other articles, because if you're in a media organization, obviously, you get paid for prolonging engagement, right? The more engagement you have with your customer, the more ads you can sell, and that's how people make money in that market, right? So, correcting grammar, I would say, is, I can't help you with that. But on the topic modeling, I think that's something I'd highly recommend you look into. Yeah. How about you guys over here? I've been over there. Anyone have any? What's anybody working on here? How are you going to apply machine learning? Yes, please.
I want to detect fraud. So basically, we see different type of fraud. Some type of keyword stuffing, basically trying to, fake a website and trying to promote a website. And the other type, we see some Chinese or Russian spammers promoting some gambling website. So I'm trying to see, how to use SageMaker or other available APIs to do those type of tasks.
So let's do fraud 101. So you have your data, right? You have your normal data. And I don't know what kind of fraud it is. In a sense, it doesn't matter. So this is how k-means works. You have all your data, you have all your points. Now, it could have many, many dimensions. In this instance, we're going to say it has 2, just so we can visualize it really simply. The way k-means works is you say, how many clusters do I think are here? You have to guess. You have to pick, right? You just put them in random spots, and then you draw a perpendicular line between those 2 spots, and then you label everything as being part of that cluster based on where you drew that line. Then you determine where's the mean of the clusters that you just created, and then you repeat and you reset and recluster. Now what's going to happen is you're going to keep repeating that until the fewest nodes, maybe not no nodes, but the fewest nodes change cluster membership. And then you're going to find anomalies. So these are the anomalies you're looking for, right? So now you've got your trained model. And you know, k-means is not always the best choice, by the way. I mean, you can use logistic regression or, you know, a couple of other means to determine anomalies. But it's probably the best for just like from a simple point of view. So those are the anomalies. Now when new data is coming in, you're going to be able to pick those off relatively easily. So that's a good first approach. One thing that I will advise you, because you're early stage in this, is that there's an enormous difference between detection and prediction, right? What we're talking about here really is not deep learning, right? It's really not very advanced. So, you know, when you detect a problem, the problem's already happened. If you can get to the point using deep learning models, and there's a lot of literature, of course, we already went through FastAI. FastAI has a lot of stuff in Jeremy Howard and Rachel Thomas put just enormously good and useful course together to begin to think about how to use convolutional and recurrent neural networks to do prediction for anomalies rather than just simple detection. And then last night we had Jason, oh my gosh, I forget his last name. What's his last name? Yeah, Tan, Jason Tan from SIFT Science. He uses ensemble modeling. Now what ensembling means is that you're taking more than one model and linking them. So he said something really brilliant. He said, you know, in the beginning we'll do detection of the process, but then later on we use predictive models to help understand how to handle some of these things. So I'm pretty sure we recorded that session, so we can go back and see it if you weren't here last night. But these are modern approaches. These are the approaches that really displace markets. So I encourage you to try to not just stick to detection, really get into prediction.
Cool.
Maybe one or two more. These are great, by the way. This is a great integration discussion. It's above average. Maybe
so
just
one quick question about this graph. So do I just use PCA to project them to a two-dimensional domain and use k-means?
Not necessarily. I did this because it's very simplistic and, you know, communicating to a large group. PCA is great, but PCA has its problems too. So I would say between PCA and k-means, agglomerative clustering is another one I recommend for marketers. These are probably the most common clustering models and dimensionality reduction models. It's going to be really specific to your use case. You should know them all.
Thank you.
One more, and then we're done. One more?
Oh, first thing.
Okay. Oh, Chaitanya. No, you're Amazon. You got to save it for
I'm coming.
customers. Yes.
So right now I'm dealing with an issue where there are a lot of visitors coming to your website. They're following the blogs and other stuff. We don't see conversion. So we're using a service called Signpost that, you know, when people opt in, they send messages. But still we're not seeing any conversion. So is there anything I can use to figure out what the behavior is?
So when you're saying we're not seeing conversion, I mean you actually at 0?
Not 0.
Right.
Very low.
Okay, so you're seeing some conversion, right? So that's your good data.
Okay.
That's what you have to dig into. Gosh, I wish I could name names. But this is not an uncommon problem. The other side of that coin is churn, right? Because you want to keep your customers. So we have built right into SageMaker example models. I think we have like 2 or 3 churn models where you can predict churn on customers. I don't know if that's the best starting point for you, though. I actually think my guidance here is to, if it's only 1 or 2% converting, to take a look at them. There's something you're doing right. It could either be that you reached out in an ad campaign and micro-segmentation through clustering again and determining what clusters they're in, go to your transaction log, really identify the characteristics, and then increase spending on those campaigns would make sense. Or it could be certain behavior or a click path or something that they did. But it's in your data.
Okay, so right now I have no idea how to collect that data. If I use SageMaker, would that help me collect the data?
So
Tell me the pattern.
that's a really good question. You do have the data. It's in your logs.
Okay.
I highly recommend working with one of our consulting competency partners. You know, you can spend a modest amount and lose the bank, but that's what these companies like Paraveda, Slalom, you know, you can just kind of check the consulting partner list. They're the ones who can really take a look at your specific use case and develop some machine learning models that get those numbers up. Yeah. All right. Thank you. Hey, thank you, everybody. This was a really fun session. I hope you enjoyed it.